Hey guys, welcome to another ChronoLogic live stream. So Joseph here with you guys today, and today we will be going through on how to integrate the Ethereum alarm clock with JavaScript into your own application. So hope you guys are all doing well. So we've been working on using YouTube from now on for these live streams. Hope you guys like it, and you have the group chat on your right hand side, and feel free to type anything in the group chat. And if you guys can hear me, could any of you like just type one or something? Okay. Okay, let's get started then. So guys, so the point of today's live stream is to go through integrating the Ethereum alarm clock with JavaScript in your own application. So what we will do now is we will go through a kind of like the simplest possible scheduling process using our Ethereum alarm clock JavaScript libraries. So what we hope to get out of this webinar is that by the end of the webinar, you guys would kind of start with using the Ethereum alarm clock JavaScript toolset to build your own applications that use scheduling on Ethereum. So let's get started with that. So before we jump into it, let's do a couple of dev updates. So us guys at ChronoLogic, we've been kind of busy with our Chronos app. We fixed a couple of issues, and there is an updated version on GitHub. So if you guys want to check that out, be sure to follow the link and update to the latest version. Another huge announcement that we have is that we have also implemented scheduling token transfers on MyCrypto. So as you guys know, we have worked closely with MyCrypto to deliver scheduling functionality, and we have done this earlier this year, and now we have upgraded this functionality to include token transfers as well. So if you go to the MyCrypto website, using the send later button, you can now schedule token transfers. So this is a huge thing, and we will do a webinar around it as well. So be sure to stay tuned around this. So today's agenda, what we have is I'll do a short introduction of the Ethereum alarm clock for the guys that are new here, and we'll do just like a small display of the tool set that we have built around the Ethereum alarm clock, and then we'll go deeper into our JavaScript library that interacts with the protocol itself, and I'll go through a short demo on how to do this. So hopefully by the end of this webinar, you guys will be able to integrate this into your own dApps. So this webinar is mostly focused on developers, and so hope for you non-developer guys, still stick around, because you will see that it is very simple to integrate the Ethereum alarm clock and to start scheduling, start building tools that schedule transactions very easily. So what is the Ethereum alarm clock? So the Ethereum alarm clock is a scheduling protocol on Ethereum. It allows you to schedule transactions for the future. So basically, it is a decentralized and incentivized open source project, and we've been working on this intensely and building out the ecosystem around the Ethereum alarm clock. One of which is today's JavaScript library that we'll be using. So basically, what the Ethereum alarm clock allows you to do is to schedule a transaction for a future point in time, using an entirely decentralized manner. So this is something that we find will be useful for many applications, such as decentralized exchanges, maybe like games on the blockchain, and so on and so forth. So what we have built around the Ethereum alarm clock is on the left-hand side, we have the protocol itself. Then we have a JavaScript library that interacts with the protocol. We have the time nodes, which are nodes that are run on the network, and they execute these transactions that other people schedule. And then we have the dApps, and the dApps are basically any applications that are built on top of the Ethereum alarm clock and utilize the library to communicate with the protocol. So today we'll be focusing mostly on the library part. So using this library, we have the link here to our GitHub page where you can read all about the library and you can check out the source code and everything. So if you go to github.com, Ethereum alarm clock /lib, you can find our Ethereum alarm clock library. So basically, this library is used to schedule transactions. So you can easily schedule transactions for the future using JavaScript. And you can also retrieve information about these scheduled transactions and then display them to your users. And so today we will go through a short demo on how to use this library and start building applications that schedule transactions. So let's get into the demo. I'll start off with a empty window of Visual Studio Code. So this is my preferred development environment, but you can basically use any development environment you want. And let's build a new project. So if we go here on the left-hand side, if we go here to add folder, just a second, I have some troubles. My mouse is not displaying. Okay. So if we go here to add a folder, let's go to this folder. I created a special live stream folder here for us. So what we will do here is let's create a new project. So let's create a new folder. We'll call this project schedule project. So once the schedule project has been created, let's start with implementing the library. So basically, what we will do here is let's open a terminal. So we'll go to terminal, a new terminal, and now we have a terminal open in this live stream folder. As we can see, our schedule project is here. So let's enter the folder. And let's create a new project. So basically, since we're using JavaScript, we will use npm. So if you haven't installed npm, be sure to install it previously. So npm is the Node package manager, and it allows you to initialize Node.js projects. So let's initialize a new project. We'll call the package name, we'll just leave it as is. We'll just leave all the defaults. So basically it says package name, schedule project, version, let's keep all of these defaults. I'll just press enter on all of these. And now it's asking me, is this okay? And it's giving me a name, a version, description, and so on and so forth. So these are just some basic parameters for Node. So we'll press yes. And if we do ls, we will see that our package.json file is now visible here. And if we go here, we can see that our package.json file is now created. So what we do now is we install a couple of libraries that are needed for this to work. So let's type npm install, and let's do --save. So we'll install the Ethereum alarm clock /lib. So this is our library, and we'll use another library called moment, and you'll see later what we use this for. So basically, this is just for some time specific things. So let's do this npm install. This might take a while. So basically, we use this moment library to create a timestamp, to create a time representation on when we want to schedule this transaction in the future. And we will use our library to interact with the protocol itself. So also on this webinar, what we will do is we will test out all of this functionality in a separate blockchain. So we will create our own blockchain using Ganache CLI. So I'm not sure if you guys are familiar with that, but basically Ganache is a tool that enables you to easily create a kind of like your own blockchain and deploy things onto this blockchain. And this is very useful in the beginning for testing, because you don't want to immediately deploy to the mainnet or to some of the testnets, but first you want to test it locally, and this is what the Ganache CLI offers us, basically. So let's wait for another second for this to finish. It should be done pretty soon. Okay. So we can see that we have a moment installed and we have our Ethereum long clock library installed. So since we have this installed, let's start our own blockchain. So we will create. I will open a new terminal window, and here what we will do is we will run npm install global Ganache CLI. So I've already run this command, but you guys can run this, and this will install the latest Ganache CLI, which is the your own kind of like local blockchain. So you would run this, but for now I will just skip running this command, and I will just go straight to running the blockchain itself. So after installing Ganache CLI, what we do is we type Ganache CLI, and we'll put a block time of 1 second. So this is basically every 1 second it will mine a block, and we will give it a identifier, a network identifier of 1002. This identifier is used for us to kind of know that this is a test network. So let's start the Ganache CLI. Okay, I see I already have a terminal running with this. I guess I didn't close it. Sorry. So let's go back. Let's try it again. I closed the previous terminal. Okay. So we have our Ganache CLI running here. We can see that these are some of our available accounts, and we are listening on the port on this IP and port. So now that we have it running in the background, let's switch back to our original project. Okay, so we are now back at our original project, and let's deploy our Ethereum alarm clock contracts. So to do this, we type npx EAC -deploy -contracts. This will deploy all the Ethereum alarm clock contracts to our local network. And this part is needed because the contracts are a core part of the Ethereum alarm clock, and we need those deployed in order to have all the scheduling functionality available. So we have created like this small script that allows you to deploy these contracts on your local network. And okay, we see that all of these contracts have been deployed, and this is done. Okay, cool. So now let's get into coding itself. So let's make this window a bit smaller, and let's create a new file. Excuse me. Let's create a new file. We'll call it Ethereum alarm clock tester. So EAC tester.js. Okay. So now we have a new file here open, and let's start sending a transaction. Let's start scheduling a transaction. So let's say we want to send, let's say, send amount to be 1 ether. So we want to send 1 ether to let's create a new variable called send2, and we will use prepared a random address here to which we will schedule this transaction to. So basically we have the amount that we want to send, and we have the address to which we want to send it to. So now we just have to specify the time at which we want to send it to. So let's see, send at. Let's call this variable send at, and let's use our moment library, the one that we installed earlier. And so this is the const moment equals require moment. So basically this part imports our moment library, and now we can do something like moment, and this will give us the current time. But let's say we want to schedule this for tomorrow at the same time. So what we can do is we can do moment.add 1 day. Okay. So technically this send at variable will now contain a time of this present moment plus 1 day. So this is the time at which we want to send our transaction. Okay, so now we have all our variables set. And now we just have to use our Ethereum long clock library to send this transaction. So first thing we want to do is we want to import our Ethereum long clock library. So what we do is we do const EAC, that's short for Ethereum alarm clock, and we do require at Ethereum alarm clock /lib. So now we have imported our Ethereum alarm clock class, which we will initialize and then later use to schedule these transactions. So what we do now is let's create an instance of this class. So new Ethereum alarm clock. And here we can see that it requires a parameter to be initialized. So it requires a Web3 object. And for you guys that are familiar with dApp development, you will know that the Web3 library, the Web3 object, is a common library that is used for building dApps. So okay, we're missing this parameter. Let's create a new variable called Web3. And let's use some of our utilities. Let's import another class from our Ethereum alarm clock lib. It's called util, and let's do util. And we have this function called get web3 from provider URL. So basically, what this function does is you give it a URL, which in our case is the URL we used on our Ganache CLI instance. So if we go back, we can see that here we had our, okay, so this was our URL. Let's copy this and paste it here under this Web3 object. Okay, we have that set, all done. Let's now use this Web3 object and paste it here. So now we have our Ethereum alarm clock class initialized. And now that we have all of this prepared, now we have now we get to the scheduling itself. So this was all in preparation for the scheduling. So let's create a new function called schedule transaction. What this function will do is it will use the Ethereum alarm clock, in this case EAC library, EAC object instance, and it will let's call a function called schedule. So we have our schedule function, and we have to give this schedule function some parameters, some scheduling options. So what we do here is we will first, let's give it a to address. So this is the address we want to send this transaction to. We want to schedule this transaction to. And since we have already defined it here, let's reuse this send to variable. So this will send to address to this address. Okay. Second thing we would want to do is we want to say how much we want to send. And in this case, there is a variable called call value. And this is this variable kind of defines, this variable is used to let the Ethereum alarm clock know how much ether, how much Wei you want to send to the recipient. So in this case, since we have this send amount already set here, so we want to send 1 ether. But since this call value accepts Wei and not ether, we have to convert this to Wei. So let's do web3.utils to Wei. Okay. So now we have our call value set. So we will set it to the Wei amount of 1 ether. And so 1 ether is 10 on the power of 18 of Wei. And the last parameter we want to use to schedule this transaction is our window start. So window start is basically the execution time. So this is what time do we want this transaction to be executed. So let's use our send at variable, and we will and let's convert it to Unix time, because the Ethereum alarm clock scheduling works with Unix timestamps. So we will just use this 1 day ahead. So basically tomorrow at this time, we will start the window of execution for this scheduled transaction. Okay, so this is basically it. By running this, we will schedule this transaction. So let's try. Let's after we schedule this transaction, let's print it. So we'll do console log, and we'll do receipt. So basically, okay, we will be printing the receipt, and at the end, let's call our function schedule transaction. Let's call it. Another thing we have to keep in mind is that this scheduling function is asynchronous. So what that means in JavaScript is we have to add the await modifier here in front of schedule, and we also have to make this function asynchronous. So we'll call it async await, and this should basically be it. So we have our whole transaction here, our whole script here, and what we can do now is try running the script and hope that it works. So what we do, we go back to our terminal, and we type node EAC tester. So this is the name of our script. And if it all worked well, we should be able to see the receipt of our scheduled transaction. And as we can see, we have this is the receipt of it. So we have the transaction hash in which it was mined. We have the block number, and we have from to, and of course we have lots of other parameters here which are not very user readable. But let's work on making it more user readable. So let's do a couple of changes in order to make sense of this receipt, to make sense of what actually happened here. So let's create a new variable called scheduled transaction, and this is where we will store all the information on the scheduled transaction itself. So what we can do is we can call another function of our EAC toolset, which is called transaction request from receipt. So what you can do is you can call this function, you can give it a receipt, and it will return a scheduled transaction object. Another thing we will do here is we will call another function called on the scheduled transaction called fill data. This transaction will basically make this method will basically make all of this data user readable. So, and instead of logging our receipt, let's log something like this: sending call value. So call value, this will be our amount. Sending our amount to, and let's do another scheduled transaction dot address. So this is the address that we are sending it to, and let's see, and we'll put a time also at scheduled transaction dot Windows start. So okay, so let's put something like this. So basically sending value to address at a specific time. So if we save this, and if we run our script again, we will see that it says sending. This is 10 to the power of 18 of way to address. Let's see. Address. And this is sending at the specific time. So instead of with, so basically we are sending. I put this incorrectly. So this address is the address of the scheduled transaction itself. So what we can do is something like let's see. sending. Okay, let's do something like this. Let's run the script again. So basically, this is our scheduled transaction, and it sends this much ether at this time. So let's, but since you see that this time is kind of like a number, so it's basically a Unix timestamp. So what we can do here is we can convert this to a more like human readable format by changing this part to be moment.unix. So this should change the look of our time. So if we run the script again, you can see that it's sending it on December 19th. So this is the day, this is tomorrow at this specific time. And this is basically it. So now we can, if we only console log our scheduled transaction, scheduled TX, and if we run the script again, we can see that it has lots of other information about this scheduled transaction, and we can kind of pick and choose which of this information we want. We can see some information about the bounties, about the transaction itself, about the time that it was scheduled, and when was it, who was it created by, and who is the owner of the transaction. We can see all of the stuff here. So you can basically play around with these options, and you can display this to your users and do whatever you wish. So basically, this is the not sure if it if it looks complex to you guys, but it's basically very simple example on how to schedule a transaction. So, and it can be easily integrated into any other systems currently. And if you guys have any questions around it, you can also you can always ask us, or you can refer to our integration guide, which is something that I could show you guys as well. So basically, if we go here, you can see that we have our, if you go to Ethereum alarm clock integration using EAC JS library, you can see that we have a document prepared for you guys called integration using EAC JavaScript library. And basically, if you go through this process, you will achieve similar results to what I have shown today. So you can always refer either to the docs, or you can also ask us, and we'll be glad to help you guys. So I guess that's it for today. Let's get ahead into QA. So if you guys have any questions, let me know, and we can kind of go through those as well. So yeah, not sure if I let me see if I can see the let me see if I can see the questions. Okay, I don't seem to be seeing any questions. So guys, so thank you very much for attending this live stream. Hope you guys enjoyed it, and we'll see you next time in our next live stream, where we'll be talking about scheduling token transfers on Ethereum. So once again, Joseph here from ChronoLogic with you guys, and I'll see you next time. Cheers.